Okay, what is effective in this context and how it compares to effectiveness to efficiency?
Hello. Well, interestingly enough, the slogan of our company is efficient people. And I had a fight with my partner because I wanted to call it effective people. But the reality is that even though I know the difference, very few people know the difference, and I don't think it matters anymore. So most of the people like to think of efficient as something really good, regardless of the resources. So most people assume that effective is efficient.
Hello. So effective is to get something done, is for a purpose. So there is a purpose, there is a desired outcome, and you are able to achieve that. Efficiency is achieving that with the minimum waste. So in general, I would try to make something work first and then make it more efficient. However, when you talk about architecture, we quite often are trying to optimize for something, and efficiency often is one of the criteria that you need to be effective. And I think that was, I was trying to think about the two, and I see that in architecture normally there is a much bigger correlation that we normally find in code. So
now is the time to ask questions.
Okay, effectiveness in the software architecture process, from my point of view, is any kind of practice that allow us to get into an effective architecture. And an effective architecture, from my point of view, is the most simplest architecture that allow us to meet the business requirements, the quality requirements that our stakeholders really care about, and to take into account all the trade-offs between these quality requirements that we find. So this is the context from my point of view about efficiency.
Thank you. So I'm going to cheer everything up and say failure. Does anyone remember a website called Friendster? Mm-hmm. Who remembers Friendster? Friendster was Facebook. It was the very first thing. You could have friends, you could create social groups, you could post stuff. And what happened is, after they got, I don't know, make up some number, 10,000, 100,000 users, it just was horrible. You'd try to refresh the website and it would take a minute or more. Eventually people gave up, and then they bounced around and they got to where we are today, which is our websites are very quick, okay? My point is, we can't underappreciate that failure is a very real possibility, right? When we talk about effectiveness or efficiency, the first step is avoiding abject failure, okay? And that's an unglamorous and it's a scary thing to think about, but tons of our pieces of software actually fail. And sometimes management tries to paint them as, oh, partial successes. But no, actually, sometimes they're just absolute failures, like the Friendster example. And that, by the way, it boiled down to they were using a relational database like MySQL, and every time you hit their website, they were hitting the single relational database, and it just didn't scale up. And that was the end of it.
So then what I'm getting is that the answer to everything is to avoid the failure, right?
So this gets into the second problem. Owen and I were sort of chatting about this earlier in terms of architectural practices. So imagine that you safely avoid your company failing. Mm-hmm. Who's the hero? Is it you, or is it the guy who wrote more code?
We should observe that probably in most industries, but in our industries, there's a lot of people rewarded for putting out fires, whereas there are very few people rewarded for being fire prevention officers. And actually quite a lot, I've always thought, when people say what is an architect, what is a technical or software architect, my glib answer has always been, oh, it's the technical risk manager, really, because that's an awful lot of architecture is balancing technical risks. And a lot of that is avoiding the fire in the first place, but whoever knew if there was going to be a fire? You can't prove the absence of something. I'm sure our science geek has got a philosophical view on that, but yeah, that's George and I chatted over lunch about this, but that was the slightly depressing conclusion we came to, is that it's quite hard sometimes to prove you've been successful.
Oh, and I think you had a great example. Is that something that you're happy to share?
Yeah, I can share. Yeah. So within Endava, I have the chief tester, chief architect, chief developer, and so on report to me. They're all great people. A big part of what they do is they build capability across all of our delivery units. So they encourage the delivery units to build skills in certain areas that we believe are important. The problem is, how do you prove, and they work completely through influence. They've sometimes got a bit of money, but no one reports to them. It's a pure influencing position, just like an architect. Their problem afterwards is always, how do they prove that they had the effect? Because, of course, one of the influencing techniques they use is to get people to think it was their idea to start with. So after all this capability has been built, it's very hard for the group heads of discipline, the people who report to me, to actually prove they've had the impact that, in fact, I know they've had, because I've seen it happen. I've seen them go through the painstaking process of persuading people to do the right thing, but again, you can't prove the absence of something.
So the people from the public are asking, do you have any examples of non-effective architecture practices from your past experience?
Model-driven architecture.
Say more.
So we should remove that in failure from the company, and then we're done?
Exactly, yeah. So some of you may be too young to remember, some of us have mental scars from a period when UML was going from being something quite useful called UML 1, and then a whole lot of people who wanted to sell a lot of very expensive case tools hijacked the standards process as it went through UML 2. People like Martin Fowler got very disillusioned and walked off. And the result was model-driven architecture, where you could describe every detail of your system inside a UML tool, as opposed to an IDE, press a button to generate code that was always incorrect, and then you could fix the code twice, once in the UML tool and once in the actual code, and then you could spend the rest of the project trying to reconcile the two. It wasn't a huge success, you'll be surprised to hear.
Any other tool that should be practice that should be removed?
Whenever the architect is not using her own architecture, then it's really painful, because everything you design has to be changed later at some point, improved. So when the architect is no longer in the project, it's a pain in the ass.
Because this is supposed to be a debate, I actually agree with Eoin, but I'm going to take up the counter position, and I'm going to make the following argument. If you are using a nice, what would we call it, an application engine or a servlet container or some sort of these things are the proper inheritors of the crown of model-driven architecture. Okay, so model-driven architecture, as it was originally envisioned, is exactly the executable specifications. There's a whole bunch of noise and so forth. But the idea was that you were trying to get as close as possible to stating your business problem, and you didn't have to deal with all the fussy infrastructure. Okay, and if you think about a modern app engine, it's handling some amount of the security for you. It's handling some amount of the load balancing for you. It's probably handling making sure your backends are up, and it's probably doing a certain amount of logging, as Len was talking about, to make sure you can trace through the RPCs and get visibility. There's a whole bunch of things it's giving you. Okay, so in some ways it changed and adapted and became a better thing. Okay,
I'm not convinced it's the same thing.
Oh, but I'm trying to disagree.
And actually, I'm not anti-code generation. I can argue with myself. As in fact, a friend of mine who's an academic points out, because he does consulting work in industry, and this is proper industrial work. It's real-time, embedded, safety-critical control. This is stuff like, if it gets it wrong, a car hits a wall. It's pretty serious stuff. And they use a lot of code generation. So it's not like I'm totally anti-code generation, but the interpretation that was done there, I just think was a bit flawed. The thing they got wrong, in my opinion, was they never quite reconciled the model bit, which is kind of what we've inherited now, is the frame, that's become framework, and the application code bit. They never quite worked out how to square the circle between the two, because I think a lot of them, at the back of their minds, were hoping they could completely get rid of programmers, and and they never quite admitted that.
I think this is a good example also of the trade-offs that we face in software architecture, because on the one hand, it is desirable to get executable specifications, okay? And on the other hand, we also want all the expressive power of generic programming languages, okay? And the tension between the two is something which is difficult to reconcile. Okay, but I think that of course, they didn't it right. Okay, all these approaches to model-driven engineering. But I think that this is a system. This is something that is actually a problem and has to be solved some way. And one of the strategies that I think that are better to address this issue are domain-specific languages, embedded domain-specific languages. Okay, not working through an external, graphical, inexpressive domain-specific language, but working within the general purpose programming languages, building your own DSL. Still, I think this is very promising, and there are techniques from functional programming to create these embedded DSLs in a very effective way, but still it's difficult nowadays to implement these embedded DSLs. But I think that the line, okay, to progress towards these goals is around that path.
So in what context do you have in mind? Of what concrete example are you thinking that the embedded DSLs can really work?
Okay, for instance, the Spark framework. The Spark framework for big data, okay, is based on an architecture. It's built on DSLs. Okay, the resilience distributed data sets, okay, are not data sets, are programs, okay, and the RDDs are the API, are the DSL that the programmer used to express and to specify their data set, distributed data set transformation programs, okay. This is an embedded DSLs, and you can program, you can create these programs within Scala, you can create this program within Python, you can create all these programs in Java, okay. You can contrast this approach from Spark, which is not only based on RDDs, but also on data frames and data sets as higher levels DSLs, okay, and you can contrast this way of implementing pipelines and workflows with graphical user interfaces that, they work very well for the happy path, but you don't have available the whole ecosystem of Java or Scala or Python. Okay, so I think that this use case of Spark is a really good example of this approach, even if the Spark architecture and the way in which these DSLs are implemented are not purely functional.
So in what other context embedded DSLs are not going to work?
The thing we're missing from languages today, at least this is my thesis, is that we're missing all the architectural constructs. This is one of the problems. There's a subset of research academics who are constantly trying to build cleverer tools to reverse the architecture out of the code, and they sort of cross over with my architecture research community, and they don't like me very much because I keep asking questions at conferences like, why do you bother? Because I'm convinced that they'll never be successful because the architecture only exists in our minds. We can't represent it directly in the code. And we get halfway there with some frameworks and libraries. They give us some architectural constructs we sort of plug in, but I think maybe the languages aren't powerful enough, or maybe we've not thought hard enough about it, but we could put DSLs into languages that allow us to represent architectural constructs. I'm thinking about things like, there's research languages like ArcJava that was done at Carnegie Mellon, I think, some years ago, where it's got first-class architectural primitives actually in the language.
So here's one where maybe I don't have to pretend I can actually have a good discussion with you about this one. But the thing is, sometimes it's we can all look at the world and we can see it in slightly different ways. So for example, talking about the embedded DSLs, in some ways your application server is an embedded DSL, right? It says this little chunk of code you plug in, it validates the incoming messages. This little chunk of code you plug in and it intercepts every message that comes in. So my point is that the application server might be written in the same language as your program, that's effectively a DSL, right? You know, you've encoded the world of application servers, and you've said these are the only things you can do. You can't do everything anymore, and that's sort of how DSLs work. And so when Eoin says maybe we haven't been super effective at expressing our architectures in code, and why would you want to reverse engineer these things, and maybe they just appear in my head, I think that many of the DevOps things that we're doing are an attempt to say, I always wanted to be able to say, check in version 5 of the code, run the tests against it, move it into the test environment. If the things still look good, then move it into the production environment, okay? And we increasingly are able to write code that does those things. And by what I mean is that every software engineer can read the code, the DevOps code, right? Whether it's Chef or Puppet or whatnot, and they can now see parts of the architecture that were only in my head before. And I think that's only a good thing.
Yeah.
Argue against DevOps, I dare you.
I'll do the last 3 years of arguing for DevOps. Yeah, that would on video. That would be great. Yeah, I think unfortunately I just agree. Yeah, it's that lots of these tools they're a sort of very isolated attempt to bring an architectural kind of primitive into code in some loose form. I'm just thinking, I mean, we're talking about architectural styles this morning. I suppose RxJava, to be fair, is sort of trying to bring the reactive style into the Java language, but I don't think we think about it that way. I think we think, what's the simplest thing we can do with an API? What can we call to kind of hide some complexity for us? As opposed to thinking maybe the other way, which is, how do I force people to structure their code, or encourage people to structure their code in a way that's much more intention revealing? I don't think we think about it that way.
You know, I still like UML.
So do I. It's my guilty secret.
Me too. Modeling with the door shut.
Yeah, precisely.
I was just wondering if the architectural constructs that you were talking about were more about, for example, business components, the division between a domain model from the delivery mechanism, because those things within a deployable unit, our programming languages are not prepared for that. We have methods, we have classes, we might have namespaces and packages, and then we have the whole system, the system boundary. But like those conceptual modules, conceptual business modules or conceptual components, I don't think, I at least don't know any programming language that allow me to explicitly define business components or different architectural divisions within my deployable unit.
Yeah, that's exactly the kind of thing. And things like component versus connector, which I know is slightly academic, but actually when you start thinking of the world in components and connectors, you get a really good separation of concerns. So yeah, I think it's exactly the kind of thing that's missing. And some people have tried with Java annotations, and they're sort of brave attempts, but it all feels very artificial and rather kind of clunky when you do it.
It is, and also there is we are very used to make everything public as well. So many Java developers and C# developers, every class we create is public, and what we are trying to do within the namespaces is reducing the boundary of that component, and that is lowering the visibility of each class. So IntelliJ now, for people that are using Java, already highlights that to you. So, this doesn't need to be public, so you can make it package protected. So reducing the scope, but you still need to make an effort into it. So for example, if you look at the programming language, it's still up to you to conceptually try to do that, but there's no construct that is a bit higher level that will make that division more explicit.
I think this is something which is a limitation of current programming languages. Okay, I think that in the future, programming languages will be especially valuable if they allow us to create and embed domain-specific languages in a more effective and easy way. Now it's true that it's very difficult to create an embedded language in Java. It is less difficult to create an embedded language, a domain-specific language in Scala. It is even less difficult to create it in Haskell, for instance. Why? Because functional programming languages are domain-specific languages that allow us to create domain-specific languages. Okay. This is a quote from Phil Wadler, which is one of the designers of Haskell. And I think that this is something that we will see more and more and more, and domain-specific languages allow us to transfer to code all our theories. This is the most effective way to make these ideas transfer and theory transferred into code. Okay, there are domain-specific languages at very different levels, at many different levels of abstractions. Yeah. We have domain-specific language, imperative programming is a domain-specific language. Okay, it's an architectural style, and it is a way. And monads, for instance, from functional programming, are precisely that. And so I think that general purpose programming languages, what they should allow us to do is to embed, okay, arbitrary architectural styles into primitives of the language. So how it is about metaprogramming.
I agree with the aspiration, but actually I'm a bit less optimistic than you are. I'm not seeing
very optimistic
anything
today
on the horizon suggesting anyone's thinking about a DSL that's suitable for adding architectural abstractions. It'd be nice if there was, but.
So I'm going to try to disagree again. And in fact, I was going to ask you if in your interest in DSLs, as you look at the different, I'm going to go back to the DevOps kind of tools as a way of expressing architecture ideas. If you think about the DevOps tools, that especially the declarative ones, which probably you're interested in because of the functional programming, do those start to approach expressing the ideas you have about architecture? Like, there is this server, it has this version of the code running on it, it is configured in the following way, and so forth. Is that sort of DSL approaching your architecture?
Not an expert in this kind of tools, okay, but anything that is declarative, okay, matches this kind of thinking. So as soon as you get some language, some configuration language, okay, and you express declaratively, okay, your intent, and then you have an interpreter or a compiler, and it could be very complex, okay, but this is the idea, to work declaratively, yeah, at any level, DevOps or web servers, okay, the controller, you have the REST, it's a specification you can have, and you actually have, okay, libraries and APIs which actually implement the REST specification as a DSL. Okay, and then the controllers that the programmers implement are the declarations that are the specifications that guide the behavior of the web server. Okay, so this kind of declarative thinking at any kind of level of abstraction, I think it matches this kind of philosophy.
And I have a question for you. How do you think we can bridge the gap between the academic and the industrial? Because we have some people here from some universities and
industrial research, I discovered.
We should hire academics to write code and see how that goes.
Except, of course, your company does, because you've got the fellowship program where they do go in and write code, so, which is slightly scary as we all use Google services. But I think it's really difficult. The two worlds, so I've been bridging the two worlds for the last 7 years because I've been completing a part-time PhD, and the two worlds are gold in completely different ways, and it's a bit like dev and ops used to be. We gold ops, completely on stability, don't change anything, and dev completely on change everything all the time, but you don't need to run it. Well, what do you know? They didn't get along too well, and there was a huge gulf in between them. What my colleague Ed Butler in Indava amusingly calls the desert of responsibility. And you sort of get the same thing between academics and industrialists. Academics are gold on, let's be clear, gaining funding and gaining citation points. And that is the game. We obviously are gold on delivering value for our businesses. That's the game. And there's this huge desert of responsibility in between. No one's responsible for driving in academia in a good direction. And when it does produce good results, no one is gold with transferring those into industry. And until something changes on one side or the other, having looked at it for 7 years, I've concluded there's no obvious way of fixing it. So, rant over.
I have a question from the public, and it might be related to your question, Carlos. So they say, how to distinguish an architecture effectiveness from the implementation one, which could be related to academics coming up with models, and then in the industry we try to apply them. How do we distinguish the both of them?
Because it hurts. So when the architecture hurts and when it's annoying, then something has to be changed.
So sometimes when I think about architects doing their job well, it's almost like we're a Monte Carlo simulation, which is that we're imagining all these different possible futures, and we're going, this one sucks. This one also is terrible. This one's even worse, you know. And what we're trying to do is, as Mark was saying, choose the least bad of these alternatives. Okay. Now, there's risks on all of them, right? So simply failing on one of them doesn't mean your architecture was horrible, or succeeding on one of them doesn't mean your architecture was great, because you can compensate for a lot of things. So yeah, I find it very challenging. But the thing is, as long as you hold dear this idea that we don't know which future we're going to have, and that along these futures there's going to be random events that we can't directly control, it still makes sense, at least from my perspective, to try to choose the best probable future. Maybe it's sort of like in that Doctor Strange, who's like, there's a million possible futures and only one of them do we defeat the bad guy, okay? You know, like we still feel like we should be trying to do that, but when you put yourself in a different chair and imagine someone looking at you and you're making these invisible plans and invisible decisions, and yet like you don't seem to be having direct influence, I can understand the frustration on both sides of this.
I'm talking about this moment when an Irish would say, Jesus. I'm talking about this kind of hurt, pain, yeah. When it's every day that you have to think too much, and there are too many surprises in the code or in the architecture. It behaves in a way that you don't expect. This surprises, I think, the number one reason to change things.
Yeah, I like the it when it hurts idea, because it is that's how, for me, architecture is a means to an end, and we need to understand what this end is, and might be quite a few ends. The architecture is there to enable a lot of things, and for me the validation is one of those things that we want to achieve, we are not able to achieve. So, for example, we can, if you want to architect, as Mark was saying in his previous talk, there were many things that we might be optimizing for, being testability, being many other things. Even things like, for example, we don't think too much, but enable people to work in parallel, right? So, because we normally focus like we are going to architect our systems towards some business goals. But larger systems, to achieve business goals, we need to construct and maintain those systems over a long period of time. And a system needs to be designed to allow people to work in parallel and maintain. And we were discussing yesterday about being robust and effective. So all of those things that we are optimizing for me, they are validation criteria. So are we not able to work in parallel? Then maybe our architecture is not helping us. Are we not able to test fast enough? Maybe there is a problem with architecture. And then, so those are for me validations of architecture. And the architecture will be good for certain things and not for others.
But I would like to say, fail as soon as possible. So if you want to try out your architecture, try to make it go live into production as soon as possible, or run some tests that are realistic to find out if it works or not as soon as possible. If you can try to go live into production in 1 month, that's going to be better than 6 months.
But you also have to acknowledge there are systems out there with horrible architectures delivering massive business value over an extended period, and there are systems that have been beautifully developed which are absolutely useless to anyone. So, you know.
But it's the cost. You know that this is a very interesting point. We were having this conversation with one of our new clients. They are a 5,000 people company, a huge organization, and we were speaking to the actual CEO with the company. And they built a massively successful company that they are one of the market leaders in US, in fact. So for example, they say, well, but we are able to deliver software to production once every month or 2 months. I think it's 2 months. So this is true, and this is a big achievement for a company like that. But what is the cost? At which cost do you do that? For example, they have 500 people in their QA team. So it is delivering value. They are massively successful, but there is a lot of waste that they have in their system that could be reduced. with a better architecture or processes.
So connected to that you're mentioning, Sandro, somebody from the audience is asking, given that you cannot make the best architecture on day one, please don't change the questions when I'm reading them. Otherwise, I get distracted, okay?
Please do.
No. Stop it. So given that you cannot make the best architecture on day one, what are the panel thoughts on architecturing being agile?
So, as we were also having a chat yesterday, we were discussing that architecture is a continuous activity. And we are not going to build the entire system in one go, mainly when you're talking about large systems, so we need to decide what you're going to optimize for in the early days. And also, there are many things you can try to do. Isolate areas for change or variability. So if there are uncertainties in the thought process or in the plan, you need to isolate that, because that will change, so it's better that when it changes doesn't affect other things. But there are many different criteria for an evolutionary architecture as well. I was trying to make a correlation between the evolution of a product, and by product I mean any kind of software that we are building, with the evolution of architecture. So we go through refinement phases. For example, when you think about an idea of a software, you think about, okay, it would be great to have this software, maybe in 5 years. But then we need to start creating a plan and say, what would be the roadmap to start building this product? So what we're going to do in the next 3 months, or what we're going to want to achieve this year. So we're going to have a 1-year roadmap with milestones every 3 months. So you are creating a strategy to build the product. And I think that the architecture should follow that strategy. So if we know what the milestones will be for the business side, we should start evolving our architecture alongside that. As we go down into the details of the product, we go down into the details of the architecture as well. So those again, this is not like a finite set of things, but this is one of the ways that you could go about that.
When architecture is seen as not something that gets done, but as something that's a continuous process, it's what Elgil Port at CGI calls a constant stream of decisions driven by the risks and costs that you're currently facing. It's also opportunities as well, I suppose. Then that's much more about seeing architecture as something that's enabling agility rather than something that's trying to, create very rigid structure to stop people changing stuff.
Thanks.
So I would like to share a very short, a series of understandings that went through my head as a result of looking at some code. Okay, so the first thought I had was, if I want to be agile, I want to get something done and then walk away from it, and if I need to change it later, I change it. Okay, sort of like the you ain't gonna need it kind of approach. And then as I was looking at some of the code that I'd written, I was a little bit unhappy because the incremental cost of making it more general was negligible. Okay, I'm not talking like take an extra 2 weeks. I'm saying like take an extra hour before checking it in. Maybe how Mark was caricaturing the George ability. But the point was, I was like, what if I just generalize it just a little bit right now? What if I think about the 3 things that might be true? Because right now they're asking me for A, but they probably want A1 and A2 and A3. Okay, so I was like, wow, I'm trying to wrestle with this decision, and I'm trying to figure out like, I need a metaphor for this, and I was thinking of it as musical chairs. So if you guys are familiar with the game, the music plays, and they keep taking one chair away, and the music stops. Everyone scrambles and tries to grab a chair, and there's this challenge of trying to be ready when the music stops. Okay, and the agility isn't just about being able to deliver that increment of functionality, but when things actually change, what are you left with? Okay, and if you could spend like 1% more time and make it twice as general, well, that seems like a smart thing to do because it enables more possible futures. Okay, and then this is the last thing. The thing I discovered was that David Parnas got there again. So we were chatting earlier about David Parnas on the criteria for decomposing a system in modules in 1971 or 72. He also wrote about this exact idea, and he said that the best way to think about programs is that you're not writing a single program, you're actually writing a small family of programs, and that when you go to write the code, you should be considering those other families that might be that next kind of program that you might be building tomorrow. And so I think that's part of what the architect is doing, is both in the small and the large, looking for those decision points and trying to make sure that you keep your options open for tomorrow.
This is also the problem of over-generality, I mean, over-engineering this your software. And this is a problem that may happen even if this level of generality is just justified, because you are building a software product line or software product family. This may happen because in order to get into this generality, okay, the level of expertise that is required by your development team is, because of the kind of techniques that needs to be used, is too high. You might not have this expert development team, and even if you have this development team of this level of expertise, the maintenance team might not have this level of expertise. So there is again a trade-off here.
So this is perfect. Now we can actually have a bit of a debate again. Okay, so like 20 years ago, this actually happened to me. I was on this project, and they said, okay, we're about to start the project. This is the very beginning, and this guy goes, great, every project needs logging. I'm going to go build a logging framework. I'll see you in 2 weeks. True story. This actually happened. Like, and so that would never happen today. Everyone would be like, no, like let's build some stories and let's start to learn something and let's try to deliver business value, okay? So here's my argument, is that I absolutely agree with you. I just think if in terms of where the seesaw, you know, goes back and forth today, we might be encouraging developers too much on the you ain't gonna need it, because I've seen concrete examples recently anyway, not of I'm going to go build a logging framework, but of actually I made the code so specific that I try to make a change later, and I've made the software so rigid it's hard to change. But interesting.
Yeah, I think that the code is. I don't think about architecture when I'm building code. So first, I'm not a believer, although people that know me know that I'm really into test-driven development and everything else. So wait to build something and then refactor, make it better. But I don't believe that for architecture. So I'm not a believer of a big design up front and try to architect a 5-year plan for a system all up front. But I certainly not a believer of trying to architect our system story by story. Right? So, for example, one thing is a small piece of code that you might decide to refactor one way or another. But for example, if I know what the milestones are, I know that in the next 3 months or 6 months, I might introduce a payment method or a shopping basket into my system. I cannot just hack that code inside my system because there are PCI compliant. So there are regulations that I need to look after as soon as I start storing certain types of data. And if I just bring that code into the middle of my system, now the whole code is under regulation. They need to bring auditors. And we had exactly a client that they had like a normal e-commerce application. And they were going live just twice a year because every time they changed their system, they had to have auditors or people coming in. And we were not even changing the payment system. So it's one of the first things we did. Let's isolate that piece of code into a separate service. And then you can evolve your e-commerce as much as you want and just leave the payment side separate. So we have a lot of clients that are in regulated industries. So again, that's why I think that one thing is to do a big design up front, and another one is do no design at all. And I think that's why if you analyze the evolution of your system in terms of milestones, you know the kind of business rules that are coming in, and I think we should be far more strategic. And do architect our system at that level. So,
I would like to also argue about the generalization thing, to have a debate. So we often underestimate the cost of undoing a generalization. So making a loop turn into a map filter is relatively easy. But when you want to do the other way around, you want to change the map filter, or you introduced RX, for example, you have the pipes, you want to go the other way around, it's much harder. It has a big cost. So I try to step away from generalization as long as the code is not a surprise. So if it's just enough but then it will surprise the user, the reader, the consumer, because it's not complete. Because I'm handling a list, but in reality, I'm just checking the first item in the list. That will be a surprise in the future. I don't want that. But otherwise, every time you introduce a generalization, you are adding some kind of abstraction. And you are potentially adding aliens in the code and more complexity.
So we're at the point where, you know, we're going to be trading anecdotes up here. Let me use Mark's example from his talk, right? And he said he had all these different components. There was like warehousing and shipping and order management and things, right? One of the things that the two alternatives he pulled out, in one of them, you had specific dependencies between two of the services. And in another one, the service would say, look, anybody can call this interface and I don't know who my customers are, right? I don't have a direct, tight coupled connection. That's all I'm really getting. I said, if you get an idea about what kind of, I agree with you, but what I'm saying is in terms of the seesaw of the balance, I see a bit too much on this specific component is connected specifically to this component, and therefore they can't be used in some general way. You could take a small amount of effort and say, anybody can call this interface now, and that's the part that I'm advocating for. I think that we've swung a bit too far, but you're right. Each one of these abstractions comes with a cost. Yep.
Another thing is the cost of change as well. And I think that what becomes complicated in certain debates is how we are seeing architecture, or at which level we are positioning architecture. Are we talking about a few classes and lines of code, or we are talking about the whole enterprise system? So, and that's exactly what I was trying to say. So certain decisions, I'm not a believer, although I'm a strong XP, extreme programming, passionate and advocate, I don't think that you build an enterprise system one story at a time, one test at a time. That's for me is a ridiculous proposition. So for example, if you're bringing a new product to your company, where does this software fit in the whole ecosystem of your system? As we were discussing yesterday, an investment bank that we worked for had more than 700 systems. So of course you need to have enterprise architecture, and you don't do that when you are test driving code. So once you decide where that system will fit into that ecosystem, there is another level. That is the solution itself. So now that I know where it's placed, there's another level down. It's like, okay, for this system, what is the solution? What's the solution scope here? And that is related to cost as well. So you need to take into a lot of risks, size of the teams, the structure of your organization, so the technologies that are available, if you need to reuse, or how this system is going to interact. So there are layers of solutions architecture, technical architecture, all the way until you get to the code. And I think that depending on which level of abstraction you are in, the higher the level, the more you need to think about, the more you need to plan, because the cost of change at that level is too high. So.
And also, this is the most important level because it is the level which is near to business. Okay, and sure, this level, the specifications at this level will change. Business requirements, business functional requirements will change. Okay, but we also have a lot of change in the infrastructure, in the tooling, in the kind of libraries that we use. Okay, so my quest, or what I will ask in the future, okay, to software architecture as a discipline, or programming languages and so forth, is that this separation of concerns, okay, between these layers are strong enough in order to isolate, okay, the changes that can be may happen in inner layers to impact in the changes to the upper layer. Okay, and this is something that nowadays it can be achieved with, I think, with the techniques that we use.
Sort of, because like as you go down in layers, so a decision made at enterprise level constrain the decisions that you make at a solution level, that you constrain the technical level, that you constrain the design of your module and services and stuff. A great example, for example, you are building a solution, and then you need to analyze your internal, all your ecosystem. So are we going to use a data lake? For example, our application, we're going to share the data lake or the data grids that the system, that the whole enterprise uses, or we're going to have our own databases and provide that information through queues or topics. So that is an enterprise decision, and that decision will constrain significantly the decisions that I'm going to do one level down. And as soon as I make the solutions, the solution architecture, for example, that understand how it's going to collaborate with the ecosystem, those decisions at that point, if you're going to use microservices, how you're going to organize our functional areas or bounded context or whatever, if you're going to use database or which technology, you're going to be Java or whatever. As soon as you start talking about the solution space, that will constrain the decisions that you make on a lower level architecture, so on and so forth, all the way to a variable level. But those are, one level is constraining the other.
But still there are many degrees of freedom, okay, at the inner layers, okay? And as far as this space of solutions, I mean, is more than one possibility. What you do not want is that choosing one of them will impact unnecessarily the upper layers.
Well, the trick in every layer is to work out what it's valuable to constrain and what it's not. I've worked at all those layers. In fact, Sandro knows, he suffered my decisions. And it's often quite hard to know what it's actually valuable to constrain and what you should just let people just get on with it, because you're just getting in the way. For some things, there's a very positive trade-off. For others, you're just making decisions for the sake of making decisions.
So as far as I understood, you need to decide at which level what to constrain, which can be described as a pre-made decision, right? So it comes from a layer above, and then you also need to simplify, because you cannot keep pushing the complexity down and keep everything at the lowest level.
And there is a cost as well. So the higher you are, the more costly it is. Not only your work, but because changing that level will change a wider ecosystem as well. That is not only you. So and those things, they need to be carefully thought up front, and we need, you cannot just emerge from TDD.
And they move at different speeds. That may be obvious, but if you're, so I was an enterprise architect for a part of the bank, and then within that you have solutions. Sandro ran one of the solutions, and then inside that you've got people who actually are structuring code every day. You cannot possibly move at the same speed, but that's why it's so important the enterprise architects don't start constraining things they don't need to, because otherwise they'll just stop forward progress.
So there was TDD mentioned, test-driven development, and there was a question from the audience. Is there a connection between TDD and architecture?
No.
Yes.
Why?
Well, architecture for me is mainly two things. It's a quality attribute, the non-functional requirements, and then the architecture style. And for the quality attributes, TDD doesn't apply very much. There be exceptions, but in general, either you design your system for I18N or it doesn't work with TDD. But then when you talk about the architecture style, there are certain decisions that you don't have to design up front, and you can leverage TDD for that, especially outside in TDD. So I think there is no black or white answer for this.
Again, for me, it's all about the level that we are in and what we call architecture or design or stuff. So of course that there's no consensus in all those names, but a way to simplify my answer. So let's say that I have a deployable unit, right? That's my service. How that deployable unit talks to the wider ecosystem, from that level onwards or upwards, is for me architecture. But the internal design of my deployable unit, that's when I start talking about software design. It's one level lower than the lowest level of architecture. Then within a deployable unit, I divide that in two levels of design. There is what I call a macro design. And the macro design, for example, if you open your deployable unit, your service, is how things are laid out. I have a delivery mechanism, I have a hexagonal architecture, I have a layer of infrastructure, I have some components, so I'm using MVC or whatever that is. So this is what is the plan. So if you were looking at from above, you know, okay, this is where things are. So this, you start thinking maybe TDD might help or not, but I still have a plan. I know that I'm going to separate my delivery mechanism from my core domain. I know that I'm going to separate my infrastructure code from my core domain and different components within my model. But the details, the classes, the methods, the how many classes, 1, 10, and that's for me where TDD shines. I can use tests, but that's not TDD. I can retrofit them or even write them first, but for the fitness functions. I can say like this module will have this kind of SLA, I want this to behave in a certain way, and I can write the test beforehand as we did at UBS in our processing all the trades and stuff. We had that. We knew what the SLA should be, and we wrote those things up front. But for me, TDD, we work at the micro, but as you start going upwards, you need to have an idea of where you are going.
Okay, so there's a very good question, I believe, which we don't have time for answering, which is, oh, are you up for it?
Thanks for letting us know.
You have 5 minutes, okay. The question says, maybe we should first answer what software architecture is?
No.
That's your answer. So I'm gonna choose another one for 5 minutes. Or maybe you wanna have a go?
So, well, I can say a couple things which are interesting. So there's one definition of software architecture talks about the decisions that you make chronologically. Ding, 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 you make them in a bunch in a row. Another talks about it in terms of how you reason about the software, okay? And that would involve coming up with some elements of the software. So you might say that the chunks of processing, which we might call components, are important to think about, and the connections between them are important to think about, and the source code that I type and the dependencies it has on other source code are important. And another element might be the computers or the database, the disk drives that I put the software on, and how the networks are connected. And if I knew those things, and we call that architecture, then I could reason through like how my program is going to behave. And I might say, you know, proposal 1 only has 1 server, and proposal 2 has 2 servers, and then I can reason about reliability about those 2 architectures. So from those kinds, you find a couple different families of definitions. One being focus on decision making, and another one that focuses on identifying the important elements that you probably want to pay attention to for reasoning. How'd I do, Len? Which one's the right definition, Len?
Okay, so I would say last question, because we're almost running out of time. I would like to end up with something practical that people can take to the office on Monday. So how do you teach effective architecture practices to your team? And how do you check that rather they're applying it or not?
Well, can I go? Yeah. Something very useful for us is that when you start a new project, make sure you have tests for all the different artifacts. So at least one example. So you develop one feature, and you add all the kind of tests that you want to have for all the pieces. And then your developers will find it easier to write more tests. So because often people are asking me, you know, how do you encourage people to write tests or do TDD? Well, give them a real example. So that's one trick. If you are starting your project and your architecture, make it testable first and give them one example.
I would not be able to answer all those questions, but there is one advice that I probably would like to give. Look at the entire solution, what's coming next in your pipeline, and see the risks. Do some risk analysis and some uncertainties. So areas that you are not quite sure how they're going to be implemented, and risks. And risks can be both business and technical risks. Analyze those things, and if you judge the risk to be too high or the uncertainty to be too high, tackle them first. Do some proof of concepts. Do some research, but tackle them first. Don't keep moving while there is a lot of risk or uncertainties.
Linking to Mark's talk, I think it's really important to teach people to learn and to learn architectural styles and new techniques, as many as possible. Okay, and in order to learn new frameworks, new libraries, new architectural styles, in our experience, it is very it has been very useful to look at architectures from the point of view of functional programming, from the point of view of DSLs, from the point of view of languages and interpreters, and from the point of view of this. This could be seen as an architectural view. Every software from a modular point of view can be understood as well as languages and interpreters. And looking to new frameworks and to new libraries from this point of view help us a lot to understand which are the trade-offs that they offer.
So one way, if you say, what are some nuggets you can take back to the office and use, something that I find incredibly valuable is making sure that people understand the three primary architecture views. One would be, anything that you can type, like your source code or configuration files and check into version control, and how those things are allowed to depend on each other. Because everybody hates sending out some code and finding somebody wagging their finger saying, no, that's not supposed to depend on that. Making it visible what those dependencies are expected to be or allowed to be. The next view is at runtime. Okay, so great, you have code and it runs. We all know how hard it is to say, I can see the class file, but how many instances show up at runtime and how are they configured at runtime? It can be very difficult. So anything you can do, again, to communicate to people how the runtime structures are supposed to work. And then finally, the deployment view, which is, and again, this is getting easier because of DevOps automation. That code that was running, is there an instance on the East Coast and West Coast of the United States and one in Europe? Because if people don't know the answers to those things, they're going to have a hard time reasoning through what good code is. So again, three primary views of modules and the runtime and the deployment.
Two quick things I'd suggest if you want to improve your architecture practice. Go back to the office, and in that 20 minutes Mark was talking about, task one, map out your stakeholders, what you think their primary needs are, and as all the stakeholders, there's lots of them, it's not just users and the team, right? There's lots of stakeholders. Where are the conflict points? And the second thing to do is do a quick, you can probably do it in your head, you know your systems really well. What are the top 7? That sounds a lot actually, but the top quality properties, and what properties do you exhibit today, and how well do those map up to what your stakeholders are expecting? That will probably give you an architecture backlog for a year.
So I think this concludes the effective architecture practices debate. I thank you very much for your timely knowledge. Thank you very much.